Greetings. This is homework assignment 11, problem 2, part 1, where we are charged that several f of v functions of a real stochastic process x of t, they may represent either or both of the following processes: an autocorrelation by setting the functional objective v equal to tau, and they may be power spectrum by setting the function v equal to omega. Now, in general, the diagram for this reflects the value of 1 from a minus alpha to a plus alpha. Now, in general, the autocorrelation of tau exists because we're dealing with the real wide sense stationary process, and we're trying to ascertain whether it's an even function, whether the correlation of tau is less than or equal to its zero value, and whether its Fourier transform is non-negative. In regard to the spectrum, power spectrum, we're trying to determine whether S of omega is non-negative. And we will show that for each of a few functions. Thank you. Greetings. This is a continuation of homework assignment 11, problem 2, part 2, where we're looking at the f function, section A, f of v equal to e to the minus absolute value of v. Now, this is possibly an autocorrelation because e to the minus absolute value of v is even. E to the minus absolute value is less than e to the absolute value of 0, obviously, and e to the minus value of v approaches 2 alpha over alpha squared plus omega squared, which is non-negative. In regard to its potential as a power spectrum, e to the minus absolute value of omega is greater than or equal to 0. Consequently, it passes that particular muster. On to the next function. This is a continuation of homework assignment 11, problem 2, part B, where we're dealing with the f function of v equal to sine squared v over v squared. Now, the possibility of an autocorrelation is the fact that sine squared tau over to tau squared, indeed it is even. Sine squared tau over tau squared is less than the limit of tau as tau approaches 0 of sine squared tau over tau squared being equal to 1. Additionally, sine squared tau over tau squared attends and approaches this particular diagrammatic rendition between a minus 2 and a plus 2, and certainly the height of 1. And this tends to imply that indeed this function is non-negative. As far as a power spectrum goes, the sine squared omega over omega squared is greater than or equal to 0. So consequently, it is non-negative. So in this case, both a auto correlation and a power spectrum are identified. We continue with another function of f. In this particular case, where it's equal to 1, where the absolute value was less than alpha, or 0 when the absolute value of v is greater than alpha. The possibility of it being an autocorrelation is no, because the Fourier transform is negative, okay, 2 sine alpha omega over omega. The possibility of a power spectrum exists since f of omega is greater than or equal to 0.